Microcontrollers are kind of small computer, embedded on a single integrated circuit. Just like personal computers, the microcontrollers consists of a processing unit, memory, and input-output peripherals. Microcontrollers are used in automatic controlled devices, like washing machines, microwave ovens, remote controls, medical devices, and all other automatically controlled devices. Now let us understand, how does these microcontrollers work? In this video, we will try to understand microcontrollers in a very simple way, and are not going to discuss all the parts of the microcontrollers. I am sure this video will build your basic understanding of microcontroller, and after watching this video, learning microcontrollers will be fun for you. So let's get started. Microcontrollers are built using digital circuit, integrated in a silicon IC. This piece of silicon is smart enough to perform a particular task, as specified by instructions given to it. If the instruction is big, it is broken in parts. Each instruction consists of an opcode, followed by data or address. Opcode, which is the first part of instruction, tells this piece of silicon what to do. The other part of instruction tells it what data is to be used, or which location of memory is to be addressed. All the instructions are stored in the ROM of the microcontroller, which is also called program memory. There is another memory space on microcontroller, which is called RAM, or data memory. The data is transferred inside the microcontroller, using a bunch of wires called data bus. An ALU is present in the microcontroller, which performs arithmetic and logical operation on data, whenever required. When an instruction comes from ROM, the microcontroller knows that it is an opcode, so it sends the opcode to the instruction register, which is then passed to the instruction decoder. The instruction decoder decodes the opcode, and gives a command to timing and control unit. The timing and control unit tells the entire microcontroller what to do. All the elements inside the microcontroller are digital circuits which have to work in a synchronized manner to execute an operation. As the opcode is processed, and the timing and control unit have enabled all the digital circuits, the microcontroller is ready for the next part of instruction, if it is required. Some instruction contains only opcode, some contains opcode followed by data, and some contains opcode followed by address. Let us take an example that the microcontroller have to move some data given in the instruction to the RAM. First, the opcode will be sent from ROM to the instruction decoder via instruction register using data bus. The decoded instruction will be transferred to the timing and control unit. The timing and control unit will enable all the circuits that will help to transfer the data, and will set the path from ROM to the specified location on the RAM. As the opcode is processed completely, the next part of the instruction, that is data, will come to the data bus, and will be transferred to the RAM at some location, as specified by the opcode. And the execution of the data will be completed. The microcontroller is now ready for next instruction. The microcontroller contains few more blocks like interrupt control, serial port, timer control, input-output ports, etc. There are many types of microcontrollers available in market. Different microcontrollers have different architecture, but their basic operation is same as I have discussed in this video. Microcontrollers understand only binary language, that contains zeros and ones. For programmers it is very difficult to code microcontrollers in binary, so they use mnemonics instead of binary bytes for their understanding while coding, which is then further compiled to machine code, before uploading to the microcontroller. This language is called assembly language. For more comfort of programmers, embedded language was developed to code microcontrollers, which is more handy and easy to remember. This video was important for my viewers to understand my future projects, that I am going to discuss in my upcoming videos. I hope you have got an idea of what goes inside a microcontroller, when it performs some complex task. Please like this video, and subscribe to my channel to stay tuned. See you next time.